So yesterday we were solving rational equations using cross multiplying. Today we're going to solve rational equations when we are going to use the LCD. So we're going to actually be canceling out fractions just like we did last week with the complex fractions. So we do have a couple steps we need to make sure of first. Step 1, we are going to multiply every term by the LCD to get rid of the fractions, just like we did with the complex fractions. Step 2, we are going to solve for the variable. And then step 3, because we're still working with fractions, we do need to check for extraneous solutions again. And in 6th period yesterday, we actually looked up the word extraneous. It means irrelevant. That's the official definition. So extraneous, when we're looking at it, we're looking at those answers that we get that are irrelevant because we can't equal them anyway. Example 1. Example 1, we have 4 over x plus x equals 5. Okay, so our first step was to multiply every term by the LCD. So remember, when we're specifying LCD, that only means we're looking at the denominators. So in my example, I only have one denominator here, and it's x. So what's my LCD going to be? X. Okay, so I just put a off to the side actually identifying what the LCD is. So what we're going to do is we're going to multiply every single term by the LCD. So we're going to multiply 4 over x by x. We're going to multiply x by x. And we're going to multiply 5 by x. What property am I actually doing? Distributive. Good. Okay. Right. So these x's are going to cancel. And we will be left with 4 plus x times x. X squared equals 5x. Okay, so now we want to solve for x. Since there is an x squared in this problem, I'm actually going to get everything over to one side so that we can use factoring to solve this. So I'm going to subtract 5x from both sides. Okay. And is everybody okay if I reorder it now so that we have x squareds first? Okay, so we're going to get x squared minus 5x plus 4 equal to 0. And then what method will I use to factor this? Diamond. So I'm looking for two numbers that add up to 4, or multiply to 4 and add up to negative 5. Negative 4, negative 1. So this is x minus 4 times x minus 1 equals 0. And then to solve this, I just set each one equal to 0. So x minus 4 equals 0, x minus 1 equals 0. So if I add 4 to both sides, I get x equals positive 4. Add 1, x equals positive 1. Okay, so those are my two answers, but we're not 100% sure that they will work. So let's check for extraneous solutions here. What's the only denominator I have to worry about? X. So we don't want that x to be 0. So what's the only thing that x cannot equal? 0. So are my two answers okay? Yeah. So my two answers for this one are x equals 4 and 1. Okay, so even though we have an addition problem here, we're only concerned about the denominators not equaling 0. So we still only have to look at the fractions and what has a denominator. Okay, and in this one, since it was just an x, there was no work to be done. Okay? All right, example 2. We have 5 over x minus 2 equals 2 over x plus 3. Okay, so the first thing we want to do is find the LCD. So we're only looking at what has denominators. In this case, the two denominators are x and x plus 3. Now remember, this x plus 3 is all together. So, are both of these factored as much as they can be? Yes? So what's my LCD going to be? X squared plus 3x, or we can just leave it as x times x plus 3, right? Let's leave it factored out because it's going to be easier for us to cancel things. Okay, so all we do is we took the two denominators and multiplied them together because we only have uncommon factors here. Okay, so we're going to multiply everything by that LCD, x times x plus 3. And this whole thing, x times x plus 3. And do some canceling. In this one, what cancels? The x's. The second term, nothing cancels. It's just multiplication. And on the right-hand side of the equal sign, those x plus 3's cancel. So let's multiply what's left over. 5 times x plus 3 is going to give me 5x times x plus 3. Oh, the x's are canceled. I didn't see that. I'm sorry. It says 5x times x plus 3. We will. Yeah. Oh my gosh. Yeah, so make sure that you have your cross out. What was I thinking? We were multiplying 5 times x plus 3. I made the mistake because I couldn't tell that I had crossed it out. Right, so it's just 5 times x plus 3. The second one is minus 2x times x plus 3. There we go. Equal to 2 times x, 2x. Okay, so we are going to distribute to make sure that we get all of our x's combined. And remember that that negative is attached to the 2x, so you have to distribute with it. Okay, so we're going to get 5x plus 15 minus 2x squared minus 6x equals 2x. Okay, let's combine like terms before we move anything around. I have just negative 2x squared here. Nothing combines with that. I have a 5x and a minus 6x, so that's going to give me minus x plus 15 equals 2x. And then let's move that 2x to the other side. So I'm going to subtract 2x from both sides. And that's going to give me negative 2x squared minus 3x plus 15 equals 0. Okay, and I do want to make sure that my x squared is positive. So I'm going to factor out the negative so that this x squared is a positive number. Okay, so we're going to factor out that negative, and we're going to get 2x squared plus 3x minus 15 equals 0. Okay. And what method am I going to use to factor this? Bottoms up. So I have that negative on the outside, and I'm going to multiply 2 times 15, so that's going to be x squared plus 3x minus 30 equals 0. And then let's use diamond on this. Two numbers that multiply to negative 30 and add up to positive 3. Is there anything? Nothing. Okay, so not factorable here. Okay, so we're going to use quadratic formula. Okay, so because we can't factor it, we have to use quadratic formula here. Okay, so that's going to give us, back to this original trinomial here, so we're looking at this one that I just underlined. Okay, we're going to use the quadratic formula. X equals negative b, so that's going to be negative 3 plus or minus square root b squared, 3 squared minus 4a, 2, c, negative 15, all divided by 2 times a, which is 2. Okay, so that's going to give me x equals negative 3 plus or minus the square root of 9. Negative 4 times 2 is negative 8. Negative 8 times negative 15 is positive 120, right? 8 times 5 is 40. Carry the 4. 8 times 1 is 8, plus 4 is 12. Yep. All over 4. Okay, so then we would get x equals negative 3 plus or minus square root.
What do you mean negative 4?
Negative 4. Oh, on the bottom, we factored out the negative. Yeah. 129 over positive 4. None of this factors out or simplifies, so that is our answer. Okay? Yeah, we don't have to do anything more with that. That's our answer. Let's check our extraneous solutions really quick. X cannot equal. Look at our denominators. Our denominators are x and x plus 3. So what are our extraneous solutions? X cannot equal 0. That's this one. Or what would make this one 0? Negative 3. So our answer is totally okay. Alright, so example 3. Here we have 1 over x minus 2. And remember that x minus 2 is together. Plus 2 equals 3x over x minus 2. So the first thing we want to do is find our LCD, which means we're only looking at the denominators. So what's my LCD going to be here? Any ideas? You could, but we do want it all factored out because things are going to cancel. So because each of these denominators are as factored as they can be, we just multiply them together. So our LCD is x minus 2 times x plus 2. And we want to leave it factored so that when we multiply, things cancel. Okay? So we multiply every single term by that LCD. X plus 2 times x minus 2. X plus 2 times x minus 2. And x plus 2 times x minus 2. Okay? And then we do whatever canceling we can. So x minus 2 and x minus 2 cancel. In the second term, nothing cancels. And on the other side of the equal sign, x plus 2 and x plus 2 cancel. So after we do that, we're going to do our multiplication. I have 1 times x plus 2, which is just x plus 2, plus 2 times x plus 2 times x minus 2 equals 3x times x minus 2 okay, and then let's distribute and combine like terms. To make things a little simpler for us, instead of distributing the 2, let's do this part first. What's x plus 2 times x minus 2? Good, x squared minus 4. It's just a difference of 2 squares, right? So this is going to be x plus 2 plus 2 times x squared minus 4. Because all 3 of these are being multiplied by together, I can change the order of the multiplication because order doesn't matter. Equals, and then we distribute on the other side of the equal sign. So that's going to be 3x squared minus 6x. And now we can distribute the 2. So that's going to be x plus 2 plus 2x squared minus 8 equals 3x squared minus 6x. Before we start doing anything, let's combine like terms. So 2x squared plus x, and 2 minus 8 gives me negative 6 equals 3x squared minus 6x. And notice that on the right-hand side I have a 3x squared, and on the right-hand side I have my 2x squared, or I mean the left-hand side. So I'm actually going to subtract all of this stuff and move it so that my x squared stay positive. Okay, so that's going to be minus x plus 6. And I ran out of room. I'm going to go over to the side. So that's going to give me 0 equals 3x squared minus 2x squared is just x squared. Negative 6x minus x is negative 7x plus 6. So I always want to make my x squareds positive, and since I had x squared on both sides, I subtracted the entire left-hand side to move it over so that I would get a positive x squared. And then we can factor this using diamond. So we would get 0 equals x minus 6 times x minus 1. So x equals positive 6 and positive 1. I set each one equal to 0 and solved. So let's check our extraneous solutions. So we're only looking at the denominators. X minus 2 equals 0 and x plus 2 equals 0. So what can x not equal? What would make this one 0? A positive 2. And what would make this one 0? Negative 2. You could put plus or minus 2. Or x cannot equal plus or minus 2. So are our two answers of positive 6 and positive 1 okay? Yep. So those are okay. Okay, this is a little bit trickier. We have x plus 1 over x plus 6 plus 1 over x equals 2x plus 1 over x plus 6. It is. The LCD is x times x plus 6. So we're only looking at the denominators here. If they have anything in common, we only have to write it once. So we only have to write x plus 6 once because it's a common factor. X plus 6 to the second power is a common multiple of these, but we're looking for the smallest one, which is why we only have to write it once. And then we also have to write whatever is uncommon, so we do have that x as well. So our LCD is x times x plus 6. So what we're going to do is we're going to multiply everything by that. I'll write it small. And this one. Okay. And then we're going to do our canceling. So x plus 6 and x plus 6 cancel there. X and x cancel there. And x plus 6 and x plus 6 cancel here. So what are we left with? We are left with x times x plus 1 plus 1 times x plus 6 equals x times 2x plus 1.
Is on the x plus 1, is that close down?
No, my pen skipped, I think. It's just an x times x plus 1. I need to get new pens. Okay, so let's distribute here, and then we'll combine like terms. So we would get x squared plus x plus x plus 6 equals 2x squared plus x. So if I combine like terms on the left, that's going to give me x squared plus 2x plus 6 equals 2x squared plus x. And we want to get everything over to one side. So will I subtract the 2x squared plus x, or will I subtract the x squared plus 2x plus 6?
The long one.
We're going to subtract the long one on the left, minus 2x minus 6, so that my x squareds are going to stay positive. So all of these are going to cancel, and I'm going to have 0 on the left equals 2x squared minus x squared is positive x squared minus x minus 6. Okay, so we would get x squared minus x minus 6 is equal to 0, because the order doesn't matter for that. And then we can factor this. What two things multiply to negative 6 and add up to negative 1? Negative 3, positive 2. Okay, so if I set each of these equal to 0, what would my answer be? X equals positive 3 and negative 2. So now we need to check our extraneous solutions, which means we're looking at the denominators here, x plus 6, x, and x plus 6. So what can x not be equal to? Negative 6, because that would make, that would make this guy 0, and? No, not negative 1. We don't care about the numerators. We're only looking at denominators. 0, because we have a denominator that's just x. So x cannot equal negative 6 or 0. So how are our answers looking? Good. So positive 3, negative 2 are okay answers. All right, our last one, 1 plus x squared, 1 over x squared equals 5 over x. What is my LCD going to be here? Just x squared. Good. So let's multiply everything by x squared.
Is that because x is a common, so there's one x?
Correct. Right. So if we were to factor x squared out, it would be x times x. And since x is just an x by itself, they have a common one. So we only have to write it once. But we have to include that uncommon one. So it would be x times x. And x squared here. Okay, so what cancels? X squared and x squared cancel. And that x cancels with one of those x's. So we are left with x squared plus 1 equals 5x. Okay, so this looks not too bad, right? Let's subtract 5x from both sides. That's going to give me x squared minus 5x plus 1 equals 0. And let's look at this. I'm going to use diamond method. Can you think of two numbers that multiply to 1 and add up to negative 5? No. So this is not factorable. So what am I going to use? Quadratic formula. Okay, so we're going to use quadratic formula. So let's plug it in. X equals negative b. B in this case is negative 5, so it's going to be negative negative 5 plus or minus square root b squared, so negative 5 squared minus 4a, a is 1, c is 1, all divided by 2 times 1. Okay, So that's going to be x equals positive 5 plus or minus. Negative 5 squared is 25. 25 minus 4 is 21. All over 2. We can't simplify that anymore, so that's going to be my answer. And what's my extraneous solution here? X cannot equal 0. So we're good.